So we're doing a little review of chapter 3. This is domain. If you had to give the domain of this, the first thing you would want to do is take that and set it in an inequality compared to 0. Do you remember which one though? You set x plus 6 and then you do some sign and then you 0. And just think about it for a second. Don't you want things under the square root to be positive? There's a sign for that. George, you remember which sign? If I just said greater, it would be close. Who's got the rest? Greater or equal to. Because it can be 0. You can take the square root of 0. The square root of 0 is just 0. So you can have it be equal to 0. That's really critical. If you didn't know that, which I know a lot of you didn't right this second, this reminder will help you survive several questions on the tester about domain. All right. Okay, so you're going to subtract 6 from both sides and solve that thing, and you got the domain. It's that easy. You just take whatever's underneath the root and set it greater or equal to 0. So we got x is greater or equal than negative 6. If I had to put this in one of these deals, I'd go negative 6 to infinity, but I'd need a bracket here. Rissy, why do I need a bracket? Because it touches negative 6. Good. It can be negative 6. All right. So whenever you have a square root, you just do that. Greater or equal to 0. This one doesn't have a square root. On this kind, you set the denominator something. X plus 5 something something 0. You know what I should set it? Do you think you want denominators to be positive? No, they can be negative. So then it's not about being positive or negative. You don't remember, but you will now. Not equal to 0. You don't want it to be 0. So this was the first time you ever used the not equal sign in an equation. And then you solve that equation. Go ahead and do that. Nunez, what do I do to both sides?
-5.
Yep. And I have x not equal negative 5. And that's true. My denominator tells me that I can't let this thing be negative 5 because otherwise there'll be a 0 on the bottom and you can't divide by 0. All right. So this is the domain, except you have to include one thing. Big R stands for all real numbers. All real numbers except negative 5. That's how you'd say that in words. A lot of kids are going to write their domain wrong. They're just going to say this part. But a domain is what you can feed the function. So basically, you can feed the function anything except negative 5. And you should be saying, what's the answer to domain? It's everything except negative 5. All right. This one, right away, I just know. If I can factor it, I should, but then I try 5 times 1 and it doesn't make 7, so I can't even factor this thing. So what's the point of this thing? Well, the domain is what can you safely feed this function? Is there any square root that could screw it up? No. Is there any denominator that could screw it up? Like, you know, there's a 1 down there. But there's nothing I could do that would screw this function up. I can't make the denominator 0 by accident. I can't make a square root negative by accident, which means what can you safely feed this function? Everything. That is a way of writing it with a number line. This is a way of writing it with an interval. And this is another way of writing it. The big R stands for all real numbers. So some people get confused on the ones that are the easiest. This one can't fail, so you can feed it anything. All right. So there's the 3 kinds of like normalish ones. One way I heard a colleague explaining this, which I'm going to start adopting and doing for the future, is whenever there's a fraction, the top is what you should start with and say, oh, I can feed that anything, can't I? Like there's no square root. There's no like restrictions. So the top would be all reals. So you go on the top, it tells me to do all reals. And then on the bottom though, I get to take out some of them and be like, oh, accept this and accept that. Let's factor the bottom because, you know, if you can factor it, you should. Chloe, I know you're new, but factoring is coming up all the time, and it will second semester too. So this factoring is critical. So on the stuff that you're working on, make sure that you practice the factoring. All right, so this has to be factored into, well, we start with x and x. Brady, how do I know the signs? Like what sign should go here and what sign should go there?
Everything's positive, so it should both be positive.
Yep, since everything's positive, they'll both be positive. And then last but not least, you have a 6, so you only have 2 choices, 6 and 1, or 2 and 3. And in this case, it's 2 and 3. All right, so remember, this told me that everything worked. This tells me what the exceptions are. So Sean, what are the 2 things it can't be?
-2 and -3.
Yep. So there's my answer. If they made me write it in interval, it'd be a pain, but it'd be negative infinity to negative 3, union, negative 3 to negative 2, union, negative 2 to infinity. That's called interval notation. Any questions? Okay, so what had happened in the fraction is we took whatever's on the top, and that tells me that everything's allowed. And then we just punch a couple holes in it for the bottom, and they kind of look like this. All right. Well, this one doesn't have a fraction. Well, everything's a fraction. It's just that the bottom is 1, and it can't be changed, and so you don't worry about the bottom. So then this defaults back to, you'd want 3x plus 1 to be what again? Greta?
Greater than or equal to 0.
Yes, and then you would solve that. Okay, let's go on to the next page. Look at how many domain questions there are. That means there's a bunch of domain questions on the final too. So let's practice this. I just told you this new, it's not really new, it's just a different way of thinking of it. That sets that everything works because there's no square root to screw up, and you don't have to worry about denominators when you're on the top. So that basically says everything works, Mr. Server. Everything works, except then you got to factor that, and it punches a couple holes in it. Sophia, can you factor that bottom part for us?
X minus 1.
You got it. And so there's 2 holes that get punched in my denominator. It was fine until all of a sudden I couldn't be 2 things. What are the 2 things it can't be?
0
All
and
right, can't be 0, can't be 10. So this says everything works. That says except a couple things. All right, I kind of like this way of doing it. But what if the top has a square root? Well, then does everything work in there? No, you can make that negative by accident, and all of a sudden you're doing square root of a negative, and that doesn't exist. So this will tell us most of the things that work, and then this will tell us that there's one exception, it can't be this. Okay, so we better do this top first. Brady, how do I do these square roots again? X minus 2 is supposed to be what kind of an inequality again? That's it. And we solve that, and let's do that. X has to be greater than or equal to 2. That sets the most of the things that work. But this could punch a hole in it. Trent, factor the bottom for me.
2 and then x minus 3.
Yep. So then what's the thing that could kill this function?
3.
So that's where I punch a hole and say it can't be 3. See how I did that? I took the top, and that told me most of the things that worked. And then I took the bottom and just punched a hole and said it can't be 3. All right. You definitely have multiple questions on domain. And the main two kinds are square roots, set them greater or equal to 0, or the kind that have a fraction like this. And in that case, it's got both parts. You set the square root part greater or equal to 0, and then punch a hole in it based on whatever makes the bottom 0. Okay, I feel like you did that well enough. Let's go on to the other worksheet. You're going to have to go back to Schoology. Now we're opening the one for chapter 4, and it's called Operations with Functions. So find that one, and I'll give you some advice for studying for that one. I'm going to get back today on the phone because you're brand new and you're not actually learning this. For future reference, you're going to use all this. I'm going to get you a key, and then I'm going to have you grade it off of that key. Actually, I could probably just grade it faster. Notice that you have your own iPad, which is cool. Could you bring it up for a second? I'm going to show you a site where you can grade this thing. Just
Wait,
bring your.
what's it called? Because my iPad's like not working right now.
I bet we can get it onto the internet if you bring it up here. We'll just have to use the guest network.
Yeah, it won't turn on, but I like charged it last night, so I don't know.
Bring it up. I'm good at this stuff. Put it down. I'll grade it for you later. Sometimes it helps to just have it. I have this long charger here. So it'll give us just a.
I think he uses this one. Yeah, this one.
Oh,
Yeah.
that's weird. Is this an actual iPad or is this like a
Yeah.
different competitor?
No, it's
Oh, okay. Oh, it's just an old one.
it's new.
Is it like super Norse or older?
Yeah.
I haven't seen this kind of charger in there. It's got this one. I think most iPads use that kind of charger. I have a feeling that it's gonna need to charge a little bit and wake up. Yeah.
Okay, then I'm gonna.
Okay. Okay, I'll do that later. Zoom in on problem 1. Everybody show me that you have found problem 1. Okay, excellent, thank you. All right. So here we go. I'm going to start with, what in the heck does that mean? That just means they're going to add the two functions together. We're just going to add f plus g. It's that easy. Okay, so here's the f function. Here's the g function. And if you just want to add them together, you just write them down. 3x plus 4 plus the other function, x squared plus 4x minus 10. That's all there is to it. Don't overthink these. Subtracting them can be more dangerous because it's the same exact thing except there's a minus right here. Like if I was doing the next one down, it would be a minus right here. And why does that? A trap. Boom, I just did it wrong. Because you need a parenthesis like that. If you don't have that parenthesis, it's not going to work. All right, so that's for subtract. And then for multiply, you got to have parentheses around both of them to multiply them. And then this has got a triple times a double. A lot of people forget that. It's right on the top 20 because kids forget it so often. So I just want to remind you, it's just distributing the 4 like you always have distributed. That's easy. And then you just also have to distribute the 3x to everything. You'll get 6 answers and you add them all up. That's how you multiply a binomial and a trinomial. Okay, so that's stuff that you could have on your test. And number 2 is just like a complete repeat of the same exact thing. You just add them, you subtract them. Remember, when you subtract them, put a parenthesis around the second one. Okay, what else would you have to know? Oh, the domain. All right, so when you divide two functions, you have to like be careful with their domain. So first off, here's the f function, x squared, over the g function, square root of x minus 8. There is my new function, f on top, g on the bottom. Are you with me so far? I just divided them. Now, do you remember just a second ago we learned how to do domain for these? The top tells me that everything works because there's no square roots to worry about. Everything works, except the bottom punches some holes in it. And in this case, the bottom has all kinds of rules. It can't be 0, and it can't be negative because you're square rooting something. So x minus 8, how do I say, has to be positive. It can't be negative, and it can't be 0. Has to be positive, greater than 0. It can't be 0 because it's on the bottom. And then that gets put on my number line, and all of a sudden, it's not all reals anymore. Okay, so when you have a fraction, we can't forget that we already knew how to do those a minute ago. The top tells you that everything works. The bottom tells you what doesn't work. All right. I'm going to do just a little bit more with this worksheet. What about functions eating functions? If you've forgotten this, please. You got to know this because we're going to do it again in second semester. So G gets eaten by F. Here's F. I write F, but with an empty parenthesis where the X was, because that's what an X is an empty parenthesis. And then what does he eat? He eats one of these. He eats the G function. And notice those parentheses are also handy because we're going to be distributing over them. And if you didn't put the parentheses, you'd forget to distribute. So a variable is always an empty parenthesis. This is the same idea, except the G function gets to eat the F function this time. All right, now on to this one. Same exact thing. They're just functions eating other functions. And inverses. Okay, this is a big last topic for the day, so focus. Inverse is where things reverse. Like if I said the inverse of black, it's white. Okay? It's like just flip-flops. All right? Well, in inverses in math, X and Y switch. So if it was the domain, it now is the range. If it was the X, now it's the Y. And they switch places. So I'll do one for you. See how this really says Y equals 3X plus 10? And then the X and Y can switch, and it's X equals 3Y plus 10. You had a whole test on this. Do you remember this? You switch X and Y, and then can you just be done? No. Like I could teach a 4th grader to switch the X and the Y. Now you have to solve it. So then we would subtract 10 from both sides. Garrett, last step. Yep. If you have headphone in still, I think you may have forgotten one in your ear. If you could take that out, that'd be good. On to find the inverse of this one. Well, Addie, I just told you the process. What do we switch first? X and Y. So the Y was here. Now it's going to be X equals square root of Y minus 7. And then what's your first step of solving it, Addie? Yep. So how do you get rid of square roots? Square it. Very good. All right. Vertical and horizontal asymptotes. We just had a test on this like literally a couple of days ago. Verticals come from the bottom. Whatever makes the bottom 0. So X equals 1. Horizontal asymptotes are the ones where we think about putting in 1,000 and see what you get. I need you to try this one. Put in 1,000 where the X is and go, oh, minus 2 doesn't really matter when you're talking about 1,000. But times by 7 does. I mean, if you 7 times my money, I would care a lot. you take away $2, I don't care very much. So put in the 1,000 and see what you get for your y asymptote. Horizontal, I call them the horizontal asymptotes to try to remind you that that's y. And the verticals, that's x equals the vertical asymptotes. Nunez, I think you might have been gone when we did this. 7,000 over 1,000, and those minus 2s and plus 1s don't really matter. Do you know what the final answer would be? I know, it's kind of crazy, but I have a feeling that you were gone when we did this. Would you agree that this is 7 times 1,000? It's not, you know, like 7 times x, right?
Yeah.
So then these can just cancel. So what's the answer now?
7.
Yeah, y equals 7. Don't forget to cancel the thousands if you can. Now, there's only 3 ways they can turn out. Basically, you either get 1 over 1,000, and what is that pretty much? 0. Or they can be like 4 times 1,000 over 1,000, and then the 1,000 just cancel, and then it would be 4. Or it could be that you have 1,000 left. After everything canceled, let's say you have 1,000 left. And what does that mean? That means there isn't any asymptote. Because if you put in 1,000 and it just goes up to 1,000, x is 1,000 and y is 1,000, it's not stopping. There's no asymptote. It just keeps going. So if you ever put in 1,000 and you get something like 1,000 back out, that means there's no asymptotes. All right, so those are the ways that this could possibly come out. In this case, we had 7 times 1,000 over 1,000, and that simplified to y equals 7. That's where the horizontal asymptote was. All right, you should be able to do this one. What's the horizontal asymptote? Well, put in 1,000. What's the vertical asymptote? That's the thing that makes the bottom 0. All right, and now on to the last page. Everybody get to number 11 here. Proving something is an inverse. We just did it. Don't you switch the x and the y around? Yes, but to prove their inverses, you have to prove that f of g of x will equal g of f of x. Process that for a second. It's not that hard. You make the one function eat the other function, and it should simplify all the way down to x. And then you make them reverse, and then the function that got eaten now is the predator, and it eats the other function, and that also should simplify down to x. So let's do it on problem 11. You need to practice one of these, or you'll never be able to pull it off on the final. And they're really not hard. Honestly, they're not hard. Make the f eat the g. Here's the f. Empty spot where the x was. Make it eat the g. Now, do you get that the 4s will cancel off because minus 4 and plus 4 cancel off? And then do you get that you'll have the square root of x squared, and then doesn't that cancel off and it's just x, right? Yeah, that's the point. It simplifies down to x. And then you do it the other way. You make the g function. Here's the g function. Make it eat a burrito of square root of x plus 4, and look what happens. The squared cancels out the square root, and then it's just x plus 4 minus 4, and then those cancel, and it's just x. And on both sides, it just simplified down to x. And when it does that, you proved that they're inverses. F of g of x has to equal g of f of x. Now, if you're being smart about how to study for finals, you're taking notes like I just gave you on this sheet, and then you can look through them right before the test. Because the kid who looks this up right before the test and goes, oh yeah, you just got to do f of g of x equals g of f of x, they'll remember what to do. Like, you know, like 5 minutes before the test starts, just look at this document and go, oh yeah, that's what I got to prove. And it'll help you so much. All right. And then even, odd, and neither is the last topic du jour of the day. So there's things you got to write down for this one that I guarantee you tons of people have forgotten. F of negative x is what you do. You make it eat a negative x. And if it comes out to f of x, that thing is even. If you make it e to negative x, and it comes out to negative 1 times f of x, then that thing is odd. Those are your two rules. Better write them down. Again, right before the final, you get a chance to review this. Like you look it over and you go, okay, so to prove odd and even, I'm going to make it e to negative, and I see what happens. If it comes out to be exactly the same as it was, it's even. If it comes out, I got to factor out a negative 1, then that's odd. All right, so let's do number 12 together. And then you can try 13 or 14 if that's your weak spot. Maybe this is something you've completely forgotten. All right, so make it e to negative x, f of negative x. And wherever x was, I make it eat a negative x. Now, do you get that the negative in there is going to cancel off and I'm back to x squared minus 4? Then you're going to finish up and go, wait a minute, that's the same exact thing it was before. So your last step is to say f of negative x was equal to f of x. See, this was f of x. And look, it's exactly the same right here. So, it's even. What if it had a negative in both spots? If there'd been a negative in both spots, like the opposite of what it was, you'd factor out the negative 1, and it would have been odd. I want to do one for you that's odd. Everybody, off to the side, write this down. F of x equals x to the third. That is an odd function. Let me just show you one that's odd. Trent, what do we feed it?
-1.
Correct. Everybody do that. Now, would the negative cancel out on this one, Sophia?
I mean, no, sorry.
Okay, it would not cancel out because it's to the third. So it's still there. Is this exactly the same as f of x? No, it's got a negative in the front. So this is the harder kind, the odd kind. It's not that hard. It's just the opposite of what it started as. So how do you finish? Well, same exact thing here. You factor out a what? -1. And then what do you have inside? X to the third. And look, that is like literally the definition. F of negative x equals -1. And that's f of x. I can tell it's right there. -1 f of x. And that is the rule for odd. That's how you prove something's odd. You feed it a negative x, and then it simplifies down. All right, now you have those two worksheets. During class today, I expect you to be working through those problems. Don't have to do them all. Should do some of them. I'd do the ones that scared me. And I would, if I got stuck, I'd walk up and ask for help. And that's all I got for you for today. Tomorrow, I'm going to actually have something that you have to do. Because if I give you too many days without any required homework, your brain's going to go to mush. But for today, you get to decide how much you do. All right, that's all I got for you for today.